on to the next concept in this unit, and that is hashing. So today we are going to focus upon static hashing. Right? So you might have learned this concept of hashing in data structures. So whatever the knowledge that you have, please tell me what you understand by this word hashing. What you understand by this word hashing? You must have studied this earlier in data structures. Yes. Anybody, please pick up.
It is used to store the keys according to indexing and retrieving the keys.
So what you are storing in hash, or how you are storing using this hashing technique, and what is the significance actually that you know why to go with hashing?
Keys can be found in fast way.
Okay, so if we are searching sequentially, then we need to search for the required data by observing the records one after another. Those are stored in a file in sequential search. But if we go for hashing, what we do is, for the search key, we directly store the address of that particular record. So in hashing, the search can be done in order of one time. So directly we can jump to that particular data by referring to our hash index or hash record. Right? So the similar concept we are going to discuss of hashing with respect to the database systems. And today we are going to cover static hashing. Right? So let us see now this important term once again, a bucket. So what we mean by a bucket with respect to the database management systems. So a bucket is a unit of storage containing one or more records. So obviously we may visualize that this is a bucket, and in this bucket we are storing the records. Right? So a bucket is a unit of storage containing one or more records. And typically a bucket is having a size of a one disk block. So usually a disk block is utilized as a bucket, wherein we are storing one or more records. Right? Now, in file organization, we obtain the bucket of a record directly from its search key value using some hash function. I'll repeat. In hash file organization, we obtain the bucket of a record directly from its search key value using some hash function. So if pictorially we would like to see this, how I'm going to depict it. See, I'm having here a black box. For this black box, let us assume that I'm having the input as the search key. So this search key value is presented to this black box, and this black box is giving me the address of the bucket where I will find my record having the search key. Right? So what is there in this black box? So in this black box, I am having a hash function. So the search key value is presented to hash function. Hash function is a mathematical function that will operate upon this search key value, and this hash function will produce some address, and if I jump to that particular address, it is possible for me to find out the record that I wanted having a particular search key. Right? So the hash function h is a function from the set of search key values to the set of bucket addresses. So I'm presenting the search key values to this hash function, and hash function is going to produce the addresses of the buckets where I have stored the data. Right? Now, this hash function is used to locate the records for extracting some information, or this hash function is being used while inserting the data or while deleting the data into the appropriate buckets. One more important point noted is records with different search key values may be mapped to the same bucket. It may happen. The records having different search key values can be mapped into the same bucket. Right? So, if I have given the input as one search key value, and if my hash function has given me the address of the bucket, it may happen sometimes that in that bucket, no doubt, I'll be having the record with the requested search key, but along with that record, I may have other records with other search keys. So whenever the address of the bucket is being given to me by this hash function, right? Sometimes if more than one search key value records are being stored in the same bucket, then I need to search that entire bucket for the required record. So it may happen. Okay. Now, let us see one example. And this example is actually giving us the idea how we are storing the records in hash file organization. So this is hash file organization. And this example is demonstrating the hash file organization of instructor file. And the key value that is used is the department name. Right? Now, let us assume that we are having 8 buckets. So, these are the buckets. Bucket 0, bucket 1, 2, 3 and so on up to bucket 7. So, these are the buckets. Okay. Now, the binary representation of the ith character is assumed to be integer I. What does this mean? Say, for example, this hash file is organized according to department name, and department name is a string. Right? Department name is the string. So, what I will do first is that string is being converted into its binary representation. Say, for example, here, music is one of the departments. Right? So, this is my search key value. Department name is my search key value. And music is one of the departments. So, this search key value music is being converted into a binary representation. So how we are going to do that? The ith character or the ith alphabet is assumed to be the integer I. What I mean, if I am having 26 alphabets, A, B, C, D and so on. So this A represents 1, this B represents 2, C represents 3, D represents 4 and so on. So if I want to find out the equivalent binary representation for this department name music, what I will do? M is the 13th alphabet. U is the 21st alphabet. S is the 19th alphabet. I is having associated number 9. And C is obviously the third alphabet. So what I will do is, whichever are these integers now associated with these alphabets, I am going to sum up these values and this will give me the value 65. Summation of all those integers will provide me this value 65. So for this search key music, the associated value that I am getting is 65. Okay, now all such department names which are in string form, those are being converted like this. Right? Now I'll be using one hash function, and this hash function will return the sum of the binary representation of the characters modulo 8. What I mean by this? The summation or the equivalent binary representation for this music obtained is 65, right? And what I'll be doing is, I'll be using a hash function like key mod 8, 8 number of buckets that I am having. Key, that is this representation for a key. So key mod 8 would be my hash function, H, right? So whenever I am computing this hash function for music, what I'll get? Hash function computed for the search key value music will provide me this 65 mod 8. So remainder, this mod function is providing me the remainder after division. So 65 divided by 8. So remainder is 1. So this hash function, modulo hash function, this is the most popular one. Key mod number of buckets is the representation of this hash function. So this hash function is giving me this value 1. So what does this indicate? This indicates that the record having the search key value music, record having department name as music, should go in bucket number 1. Right? So see here in this bucket 1, I am having the record with the search key value music, because my hash function has redirected me to go to this address, bucket number 1. So I am having in this bucket 1 this particular record with department name music. Department name is my key. Is that correct? Are you getting me? Yes?
Yes, ma'am.
Is that clear?
Yes, ma'am.
Right. So similarly, see here, if I am having so many different records with different key values for department, right? So please tell me now, in which bucket my physics, this record will go? Fourth record with the key value physics, where it will go, in which bucket? Yes? Just find it out. Yes, anybody? How we should compute this?
Third bucket.
Third bucket. Why third bucket? Your answer is
After
correct. It should go in third bucket. But what is the reason?
summation of numbers of
So this is the keyword, that is physics, right? So what we should have here, we should add the respective integers, right? So P is the 16th alphabet, H is, yes, speak up. Your computer is 8th alphabet, Y is
25,
25th, yes, S
19,
19, correct. I
9,
9, correct. C
3,
3, right? And once again S,
19,
it is 19. So what is the summation?
9,
Yes, what is the summation?
99,
99 is the summation. So 99 mod 8. So what is the possible answer now here?
3.
3. So this record with department name as physics should go into bucket number 3. So if we want to insert, then also we are following the same step, similar steps, and we'll be finding out the bucket where we need to insert that record. If we want to search for a particular data from our database, once again, we need to use the search key value, we need to apply the hash function, we need to find out the bucket wherein we can find that record. If I want to delete a particular record, once again, I need to follow the similar steps to reach to a particular bucket, and in that particular bucket, I need to search for a record that I want to delete, and then I'll be deleting that record. Right? As I stated earlier, it may happen that more than one search key values are present in a single bucket. It is possible. Right now, for simplicity, we are assuming that one bucket contains only 4 records. But in reality, it is not the case. In one bucket, depending on the size of the record that we are storing, right? Depending on the size of the records, we may store many such records in a single bucket. And typically the bucket size is our disk block. So 4 KB or 8 KB, kilobytes. So how many records we can accommodate in one disk block? Those many records we can accommodate in one bucket also. right? So I hope you must have understood how such kinds of hash such kinds of files are being organized using hash file organization. So this is what we mean by hash file organization. If you have any doubt, please let me know. Yes. Is there any doubt?
No, ma'am.
Right. So let us talk about hash functions. Right? So you might have studied this also in data structures. We may have many different kinds of hash functions, right? But while selecting particular hash functions, we should follow certain norms, right? I'll repeat, while selecting a particular hash function, we should follow certain norms. So we should consider certain points while selecting the hash function. The worst hash function, I'm saying the worst hash function actually maps all search key values to the same bucket. I'll repeat, if I'm selecting a hash function, then I'll say that this hash function is performing worst. When I'll say that if this hash function is mapping all the search key values in the same bucket, then what will happen? All the search key values, all the records will go in the same bucket. So once again, the access time required is proportional to the number of search key values those are present in my file. Right? So this is the worst situation that I may have. So I need not select such a hash function which will put or which will map all the search key values in the same bucket. So ideally, the hash function should be uniform. Ideally, the hash function should be uniform. That means each bucket, listen to me carefully, each bucket is assigned the same number of search key values, same number of search key values from the set of all possible values. What we mean by that? Ideally, we are saying the ideal situations. Ideally, our hash function should be uniform, meaning each bucket is assigned the same number of search key values. Meaning, say for example, if I'm having 3 buckets, right? And let us assume I'm having 30 search key values. 30 search key values and 3 buckets. Then typically, ideally, I need to find out the hash function such that in every bucket, I will have 10 search key values. Ideally. Okay? Are you getting me? Yes? Are you getting me? Yes. What is meaning of uniform hash function? The function is uniform, meaning each bucket is assigned the same number of search key values. Search key values. So if I'm having 3 buckets and if I'm having 30 search key values and if my function is distributing 10 search key values per bucket, then I'll say that this function is uniform. Let us assume one scenario. Let us assume that we decide to have, say, 26 buckets, one per alphabet. We are having 26 alphabets. So let us assume that we are having 26 buckets, one per alphabet. And we define a hash function that maps names beginning with ith letter of the alphabet to the ith bucket. I'll repeat. What I'm having? I'm having 26 buckets, one per alphabet, right? And we are defining a hash function that maps names beginning with ith letter of the alphabet to the ith bucket. Right? So if I'm going with such kind of a hash function, then this hash function is really very simple. Right? But if I go with such a hash function, then this is not uniform. This hash function is not uniform. Why? Because what we are expecting, what our hash function is doing, our hash function will assign the search key values or the names beginning with ith letter. My hash function is assigning these records the ith bucket, right? But usually if we look at the names those begin with the letters such as B, R, S are more than the letters or the names those begin with the letters such as Q, X, Z and so on. Do you agree with me? If I'm considering the names, right? The names those begin with the letters such as B, R, S are more than the names those begin with the letters such as Q, X, Z and so on. Correct? And if we are having such kind of a hash function which will refer to the first letter of the name, right? And depending on whatever is the first letter, it will put that record into that particular bucket. So if the name begins with B, then that record will go into the second bucket. If the name begins with S, then that record will go into 19th bucket. Right? And if the name begins with Z, then that should go into 26th bucket. Now, if I look at the names, popular names, then I may say that the names beginning with B or R or S are more. So obviously, more number of search keys will go into these respective buckets. Whereas the names beginning with the letters like Q, X, Z are less. So very few search keys will go into those respective buckets. Are you getting me? Yes?
Yes, ma'am.
So obviously the distribution of the search key values in this situation will be not uniform. So we should avoid such kinds of hash functions. I hope you must have understood the concept, what we mean by a hash function that is uniform. Now, the second property is our hash function should be random. So what we mean by hash function that is random? Meaning each bucket will have the same number of records, irrespective of the actual distribution of search key values in the file. I'll repeat. Ideally, we may search for a hash function that is random, meaning each bucket will have the same number or uniform number of records assigned to that bucket irrespective of actual distribution of search key values. What does this mean? Now, suppose that we want a hash function on the search key value. Let us assume once again that we are considering instructor table, and let us assume now that the search key value that we have is salary. Right? So we want to devise the hash function based on this search key value salary. Let us assume that the minimum salary is say 30,000. Let us assume minimum salary is say 30,000 and the maximum salary, so this is the minimum salary, and let us assume that the maximum salary is say 1,30,000. Right? And now we are going to use a hash function that divides the values into 10 ranges, suppose. Meaning the values from 30,000 to 40,000. The next range of values is say 40,001 to say 50,000. The next range might be 50,001 to 60,000 and so on. Right? So we are using a hash function that divides the values into 10 ranges like this. Now, if we look at this particular example, then definitely the distribution of search key values is uniform. Search key values are distributed uniformly. In each bucket, we are having 10,000 search key values. Correct? So, the distribution of search key values in this case is uniform. Right? Are you getting me? Are you getting me? Yes? Is there any doubt so far?
No, ma'am.
Fine. So, if we have selected the hash function that is distributing the search key values uniformly into the buckets, then this condition is satisfied. The distribution of search key values is uniform, is same. But this hash function is not random. And why I am saying that this hash function is not random? The reason is, see for example, there are more instructors, suppose there are more instructors who are having the salary in the range 60,000 to 70,000. So, many number of records will go into this particular bucket. There are very few instructors who are having the salary say in this range 30,000 to 40,000, or in the last range, say 1,20,000 to 1,30,000. So in this case, if we have selected such kind of a uniform hash function which is storing same number of key values in individual bucket, this function is not random because obviously the data, the records related to one of the range of values are more than the other range of values, and that is why the distribution of the records in respective buckets is not uniform. It is not possible to have same number of records in each bucket because maximum number of records will be in maybe 50 to 60,000 range or 60,000 to 70,000 range, and very few records in other buckets. So once again, this kind of hash function, even though it is uniform, it is not random. So ultimately, what I would like to insist is we should think of the hash function which is uniform as well as which is random. So we should have a good trade-off between these two. We should think of the hash function that is also uniformly distributing the search key values in the buckets, and also the hash function should uniformly distribute the number of records also into the buckets. Otherwise, it may happen that few of the buckets will get full and few of the buckets will remain empty. This should not happen. Right? So I hope you must have understood this concept. Right? So the typical hash functions usually perform the computation on the internal binary representations of the search keys. So we have seen one such internal binary representation. So if I am talking about a search key as the department name, then what I'll do is the representation of every individual character is being considered, that is being summed up, and we are using the key modulo number of buckets as the hash function to be used to distribute the data in respective buckets. Right? So, as I stated, we are going to discuss two more points with respect to static hashing, and then we are going to conclude this session. Right? So, let us talk about now how to handle the bucket overflows. So, there are several reasons why we are having bucket overflows. So, what is bucket overflow actually? If I want to store the records in a bucket, and if that bucket is full and still I am having several records to be stored, then obviously the records cannot be accommodated into that particular bucket. So there is a bucket overflow. So what are the reasons for bucket overflow? The very first reason why we are having the bucket overflows is insufficient buckets. So let us assume that the number of buckets are denoted as NB. Right? The number of records is denoted as NR. And FR denotes the number of records that will fit in a bucket, in a single bucket. So what we have? What is NB? NB is the number of buckets. Right? What is NR? NR, total number of records. right? And what is FR? FR is the number of records that will fit in one bucket. Number of records that fit in one bucket. Right? So, obviously, this particular discussion assumes that we know the number of total records, those we would like to store, approximately at least. Right? So, we may face the problem of insufficient buckets. So, if the number of buckets allocated are insufficient, then we may face this problem of bucket overflow. And that is why the guideline is you should always select the number of buckets NB which is greater than NR divided by FR. Total number of records divided by the number of records that fit in one bucket. So always while selecting the number of buckets selected should be, this count selected should be such that it should be greater than NR divided by FR. The second reason for bucket overflow is the skew in distribution of records. The skew in distribution of records. What we mean by skew? This means that some buckets are assigned more records than others. I'll repeat, some buckets are assigned more records than others. So, a bucket may overflow even other buckets still are having the space. So, such kind of a situation is known as skew. Right? So, what are the possible reasons why we are having this skew in distribution of records? The one reason might be multiple records are having the same search key value. Multiple records are having the same search key value. So what will happen in this situation? All those records will go into a single bucket, right? And obviously, there would be the bucket overflow. The second reason that the chosen hash function produces the non-uniform distribution of key values. I'll repeat, the second reason is chosen hash function is producing non-uniform distribution of key values. In this situation also, it may happen that one bucket is empty and other bucket is having lots of records or search key values. So, in both the situations, we may face this problem of skew, and that is one more reason for bucket overflows. Right? So, even though we face this problem of bucket overflow and even though we are knowing these reasons for bucket overflow, there should be some way, right, to overcome this problem. So the probability of bucket overflow can be reduced to some extent. And how we can do that? As I stated, this NB should be greater than NR by FR. But more specifically, this number of buckets are decided such that it is equal to NR divided by FR into 1 plus D. So this D is known as the fudge factor, and typically this fudge factor D is 0.2. Right? So although the probability of bucket overflow can be reduced, it cannot be eliminated. Right? So simply this, how to interpret this concept. Typically, we assign 20% more number of buckets than required. I'll repeat, usually we assign 20% more number of buckets than required, so that at least to some extent we can overcome this problem of bucket overflow. But even though this problem can be handled to some extent, this problem cannot be eliminated totally. So if we would like to handle this problem of bucket overflow, we need to make use of some additional buckets known as overflow buckets. So what this concept is? See here, suppose this bucket 1 is full. Then we create one more bucket wherein we may store the data. Right? If this bucket is also full, we may have additional overflow bucket. Right? So this data is being stored into the overflow buckets, and these overflow buckets are being chained in a linked list fashion. Right? So the overflow buckets of a given bucket are chained in a linked list. So this is one solution to handle this bucket overflow. So we may use overflow chaining of the buckets. This scheme of overflow chaining is known as closed hashing. It is known as closed hashing. Right? There is another method also, that is known as open hashing. Right? But in this open hashing, we are not using the overflow buckets. But what it does is, if one bucket is full, then there is a kind of linear probing. So if the bucket is full, the system checks whether the next bucket is having the space. If the next bucket is having the space, then the data is being placed into the next bucket, and so on. So this is the technique known as open hashing, wherein typically the linear probing mechanism is being used. And we go on searching the availability of buckets to store that data if the original bucket is full. Right? But this kind of open hashing techniques are not being used in database applications. So we are not going into the details of this open hashing. In database systems, the closed hashing mechanisms are being used. Right? So we know now what is static hashing, what are the properties, ideally how to select the hash function, right? How to handle the bucket overflows, what are the reason for bucket overflows, and how to handle the bucket overflows, right? What are the techniques for that? So in the next class, we are going to discuss about hash indices. We have seen how to organize the records using hash file organization. We have discussed that. In the next class, we are going to discuss about hash indices. Then we'll look for few of the disadvantages of static hashing, and in the next class, we'll discuss about dynamic hashing. Right? So I hope